In this video, I'm going to show you how to use an Arduino to read voltage, and then I'm also going to show you how to use a current sensor to read current, and that current is actually going to be changed into a voltage so the Arduino can also measure that voltage too. And then we're going to do some calculations and show you what actual current is being read. So the first thing I'm going to show you here is we have a Arduino program. I'm not going to run you through everything, but I'm going to show you basically what you need to know. We're going to be monitoring this on an LCD display. If you want to know more information about how to hook up LCD displays with the Arduino, then check out one of my previous videos. I talk all about that. But this video, I'm going to show you how to do basically how to just read the current and the voltage, and then I'm also going to put those two together and you get power. Then we're also going to use the power measurement and put that into kilowatt hour, not kilowatt, watt hours. So the first part of our code right here, you can see is we named all of our variables, and then we go into the setup routine here. This analog reference is just, we're just setting it to default like we did before in the previous videos. We have our LCD. We're using a 20 by 4 LCD display, so that's 20 by 4 characters. We have our variable set to 0, basically to initialize them. And then here's our main program. We're in the loop now, and our first thing we're going to do is read the voltage. So we set our volts variable equal to the analog read of the sense pin V, which we defined above. Now, the reason why we're dividing this by 218 is because there's 1024 bits of resolution in the Arduino for voltage in the analog pins. So in order to adjust that to 0 through 5 instead of 0 through 1024, we divided by 204.8. That gives you 5. Well, unfortunately, we can't get an exact value when we do that, so we had to tweak it a little bit. So the more precise number turns out to be 218. That gives us a more accurate reading with accordance with our voltmeter. So it actually agrees with the Arduino reading. The reason why we multiplied it by 7, that is because we have this whole thing hooked up to a circuit that we want to be able to read up to 35 volts. So in order to read up to 35 volts, we have a voltage divider, and if you do basic Ohm's law with these two resistors, and you have a 35 volts, you can say it'll be 5 volts on this output. So basically 0 through 35 volts will give you 0 through 5 volts. So basically it's like the same scaling that the Arduino does, but this one is basically doing it the opposite direction. So we're changing a higher voltage into, or scaling it down to a lower voltage, because the Arduino can only read between 0 and 5 volts. Now, in order to get that back to the 35 volts, we multiply it by 7. And you can see right here, it's multiplied by 7. So that's our voltage reading. We have a little if statement. So if the voltage is less than 0, then the voltage equals 0, because we don't want to be sitting here when it's hovering around 0 volts, it goes into the negative. So we don't want to be seeing the negative voltages, because it's going to mess up our readings. I'll show you that in a few minutes. Current, basically the same thing as above, but we tweaked this number to be more exact. It was actually 212. The reason why we minus 2.55 right here is because the current sensor, if it's 0 amps, then it will read about 2.5 volts, and the exact reading we got was about 2.55 volts. The reason why it sits at 2.5 volts is because this current sensor can read plus currents and negative currents. So it goes between 0 and 5 volts, and 0, or going towards the 0 direction, would be a negative current. Going towards the 5 volt direction would be a positive current. And then we have another loop here, or I'm sorry, another if statement here. If the current is less than 0, than just set it to 0, because we're not trying to have, we're not going to be reading anything that's in the negative. So it's basically the same thing as an absolute value, but we're not doing an absolute value, because anything negative, it'll make it positive, and it'll give us false readings. So I just figured it'd be easier just to do a couple quick if statements. Okay, now we set our power variables equal to the voltage times current, and then we have our power watt hours. So I have just power WH. This is equal to the power reading that we get up here, divided by 3600, because that's how many seconds are in an hour, and it goes through this whole loop every 1 second, because you can see down here, there's a delay of 1 second, and that's the only delay we have in this program. So it goes through this loop, basically, and it delays it once every second. So this is going to be our power divided by 3600 will give us, plus itself will give us our watt hours. Then we have this is basically all the same stuff I showed you in my previous video about LCD displays, so I'm not going to go through all the details here, but I will say that we set our first reading to be volts. Our second reading, which is right next to it, you can see the cursor is set to 10, is going to be our current reading. We got volts and amps. The next line down is going to be our power reading in watts, and then the 10 spots over, I'm going to also set the watt hours, the power in watt hours, and then you can see watt hours right here. The delays, the next line is going to be our time elapsed, and then the line below that is going to be our timer. This timer, actually, I set this up to, I don't know if there's an easier way of doing this or not, but the way I made this timer so it looks like it's actually in seconds and minutes is I named a few different variables. I put a timer minute variable, timer min. I did a timer sec2, timer sec1, and these are equal. The timer sec1 is actually going to be the seconds on the far right, the one digit to the far right. Timer sec2 is going to be the second right after the colon, that character, and then let's see, the timer min is going to be basically the characters to the left of the colon, which is the minutes. And we're not going to be running this very long, so I'm not going to do hours. We'll just worry about minutes and seconds. So timer sec1 is, since that's basically every second, it's just since it's the delay of 1 second up here, timer sec1 equals timer sec1 plus 1, because every time it loops through this loop, then it'll change it, it'll increase it by 1 second. I also have another timer variable right here. And let me see here. Actually, I don't need this variable anymore. This was something I was doing before that I don't need anymore. So forget I just said that. The next thing we're going to do here is there's a couple if statements. If timer sec1 is greater than 9, increment timer sec2, because timer sec2 is basically the digit right after the colon. So that'll get incremented by 1. And then you can set, and it also says to reset timer sec1 to 0. So basically, if it goes 0, 1, 2, 3 all the way up to 9, and then it reaches 10, it'll reset that digit that's on the far right to 0, and then timer sec2, which is the digit right after the colon, will get incremented by 1. And then the second if statement is if timer sec2, which is the one right after the colon, is greater than 5, reset that one to 0 and increment the minute. So timer min plus 1. So that's basically how I did the timer. So I don't know if there's an easier way of doing that, but that's basically the easiest way I can think of doing it. So that's it for the program. And I will show you, this is the, let me back up a little bit here. This is the current sensor we're using. It's an ACS712 current sensor. It's a 30 amp module. These up here, these pins up here, this is the positive. You basically this is what reads the current, these two pins. And if you know how to read current, you need to break the circuit. So the positive side of your circuit will go onto this screw right here, this pin, and then the negative side going towards the negative side of the battery go on this side. and any current that's flowing through here will get read through this chip, and then as long as you have 5 volts hooked up to VCC and ground hooked to ground, your output will get a voltage for a certain amount of current. The current reading is here's a 5 volt power supply, measuring range that goes up to 30 amps. Now your current reading is for every amp will be 0.66 volt or 0.066 volts, so 66 millivolts. So for every 66 millivolts you get, that's basically an amp. So I can go back and show you our calculation here. Let's see, current. That's where this 0.66 comes into play. Zoom in here. So just so you can see, current equals the reading from the pin divided by the 212 minus the 2.55, like I told you before, but we divide it by 66 millivolts, and it's actually, the exact number is like 2/3, so I just put a whole bunch of 6's here and then a 7. That way I get a more precise reading. So that's how we measure our current, and that's just the circuit right here for it. This just shows you the circuit. So that's pretty much it for the program and the specifications. Now let me take you over here and actually show you the working model. So here is the Arduino on the left. I have our voltage divider right here. Here's obviously this is the LCD. You can see the timer going. Just keeps on going, and obviously you can see it'll reset once it reaches 0, or once it reaches 59, it'll get to the next minute. So our timer's working good. Here is our voltage, current, power, and here's our watt hours. So that's the power measured in watt hours. So if I also have the sensor up here. So there's the current sensor all hooked up, and it's got a 25 ohm power resistor. So there it is. Now I'm going to turn on, or I'm going to close the circuit, so that way you get some current going through the power resistor, and you'll see the current and the wattage go on. So if you do the calculations, it's about 1 amp for a 25 ohm resistor, and you see it's hovering around 25 or so watts, and you can see the watt hours is incrementing. When I shut it off, current and wattage goes to 0 like they should, and your watt hours stop, and that should too. So that's pretty much it. That's pretty much everything for how to measure voltage, current, and power, and also get your power consumption with watt hours. So thank you very much for watching, and have a good day.